Welcome to Bernie's Tech Bureau. Today we are kicking off the construction of Kelvin the Clever Cricket, an Altronics kit that brings a tiny, chirping creature to life. This build blends classic soldering with a pick-driven brain that reacts to light and temperature, a perfect mix of fun and technical challenge. Let's get into it and start bringing Kelvin to life. Kelvin, say hello. Kelvin the Clever Cricket kit arrives in a compact, self-contained plastic box, sturdy, neatly presented, and designed to keep everything protected during transport. Inside the packaging, the first thing you'll find is the printed circuit diagram, along with a separate booklet. That booklet goes beyond simple assembly notes. It explains the circuit operation, the behavior of the PIC microcontroller, and provides step-by-step instructions for putting the kit together. The PCB itself is clearly silk-screened, with all component positions and identifiers marked, making the assembly process far easier, especially for beginners or anyone returning to kit building after a break. All of the electronic components, which I'll go through in detail in the video, come sealed together in a single plastic packet. This keeps everything organized and ensures nothing goes missing before you start the build. For copyright reasons, I can't show the circuit diagram on screen, but rest assured it's included in the kit and provides a complete reference for how Kelvin's chirping behavior is generated. With everything laid out and accounted for, we are ready to move on to the assembly. Kelvin features 16 selectable modes, allowing both day and or night operation. These modes control how he measures environmental changes and how his random chirping behavior is generated. In modes 1, 5, 9, and 13, Kelvin gives one chirp for every degree Celsius. Other modes count the degrees in groups and chirps accordingly. As he chirps, Kelvin's red LED eyes flash in sync, bringing his little electronic personality to life. From the supplied plastic parts bag, each component makes its entrance. By the end of the stop-motion sequence, the entire contents of the plastic bag are laid out in crisp, labeled order, a clear visual map of every part that will come together in the build ahead. Next, shown are the labeled components. They are the resistors, capacitors, red LEDs, the PIC microcontroller and its 8-pin socket, the piezo buzzer and a short length of solder, 2 gauges of hookup wire, 0.5 mm and 1.25 mm in diameter, the LDR, ready to react to changing light, and the NTC thermistor, waiting to respond to heat, a power diode used for circuit protection, the CR2032 lithium cell and its matching button cell holder. Finally, we have the screws and nuts, a power test switch, header and pins, and a short length of heat shrink, completing the full inventory. Note: because lithium coin cell batteries pose a serious hazard to young children, I've chosen to modify Kelvin to use a 2 AAA alkaline battery holder instead. 2 AAA cells provide the correct 3-volt operating voltage while avoiding the risks associated with button cells. Begin construction by installing the 6 resistors. Before placing each one, verify its value with a multimeter to ensure accuracy. The color codes for the 4-band resistors are listed in the parts sheet, but with only 4 different values in the kit, It's straightforward to keep them organized and avoid mix-ups. I begin by cleaning the leads of each resistor with isopropyl alcohol. Removing contaminants ensures reliable solder flow and helps prevent cold solder joints, which can lead to weak connections and eventual electronic failure. Once the cleaning stage is complete, we are ready to mount the resistors onto the PCB. I start by shaping each resistor using a pair of round nose pliers. This gives me a smooth, even bend that matches the pad spacing on the board. With the leads formed, each resistor is placed into its correct position on the PCB. Once seated, I trim the excess lead length so the pads are neat and ready for soldering. This preparation ensures the components sit flat, the joints are clean, and the soldering stage goes smoothly. I have set the iron to 360 degrees Celsius and fitted a small tip for precise control. Soldering begins by placing the tip on the pad and touching the resistor lead to create a solid heat bridge, allowing the solder to flow and bond the joint properly. Each joint is checked for a clean, reliable finish, and any excess flux is removed with isopropyl alcohol. Once I'm satisfied with the result, I move steadily through the remaining resistors, keeping the focus on consistent wetting and high reliability solder joints. I will mount the remaining 5 resistors off camera to keep the video moving efficiently. With all 6 resistors now installed and checked for quality, the first stage of the build is officially complete. I'm really happy with how the board has come together so far. Thanks for watching, and I look forward to having you join me in part 2 as we continue the construction.